Here we want to solve the systems of equations. We have x minus 2y equals negative 6 and negative 2x plus 4y equals 12. All right, so here we notice that this x variable has a coefficient of 1. Okay, so in this particular case, it may be easier to isolate this variable, right, and then use substitution here. Okay, so x minus 2y equals negative 6. Let's add the 2y to the other side. We get x equals 2y minus 6. Okay, and that the good thing about this is we can substitute this expression into that variable here, right? So let's do that. Negative 2 times x plus 4y is equal to 12. Notice I put a parentheses here instead of the x, right? Because what are we going to put in this place here? Well, we're going to put that 2y minus 6. And now we should be able to solve this for y, right? Well, let's distribute the negative 2 here. So negative 4y plus 12 plus 4y equals 12. And wait a minute, notice what happens here, right? Negative 4y plus 4y cancels out. So what's remaining? 12 equals 12, okay? This is what's called a conditional statement, right? But what does that mean in terms of the original equations, right? These are lines. It means that these lines are the same exact line. They have the same slope and the same exact y-intercept, okay? Now in this case, there's a particular way to write the final answer, right? We don't say infinitely many solutions or all real numbers or negative infinity to infinity. Okay, so we have to write this in set builder notation. Okay, so we're going to do the symbol for the set here and parentheses x comma y, right? So this means all ordered pairs, right? Remember, there's infinitely many solutions, right? Every point on this line is a solution. But we're not going to actually sit down and list out every ordered pair that works, right? So what this does is sort of takes care of that for us, right? This is saying the set of all ordered pairs such that x minus 2y is equal to negative 6. Okay? So what this does is it gives us a mechanism to give the final answer, okay, without having to actually list out every single ordered pair. Okay, so in set builder notation, this notation will always be the same, right? The only thing that will change is this, right? And in this spot here, all we have to do is write down one of the equations. Right, remember, these are the same exact line, okay? So make sure you memorize the format here for set builder notation when it's infinitely many solutions.